Caribou are in the news a lot lately in Canada, but not for good reasons. Most of the attention is focused on the population declines of woodland caribou in British Columbia and Alberta, which have resulted from land use changes connected to the forestry, oil, and gas industries. In Yukon's northern boreal mountains, caribou occur in far more remote areas, and human disturbance plays a much smaller role. Changing fire regimes in this region have the potential to affect caribou populations by altering the abundance and distribution of lichen, which is a major food source for caribou, especially during the winter. The goal of this portion of my research is to estimate the spatial coverage of terrestrial lichen across several caribou ranges. Once we know this, we can better understand how lichen affects their movements, their habitat selection, and their demography. But mapping lichen over vast and remote areas is challenging. There's a huge gap in sampling scale for measuring lichen cover. The intensive ground-based measurements that we use are often too fine scale and not very representative of an entire landscape. But on the other hand, satellite imagery lacks the necessary resolution to discern vegetation features and lichen patches. So we decided to try collecting data with unmanned aerial vehicles, or UAVs. UAVs are cheap, readily available, they're easy to operate, and they provide high-resolution imagery that can serve to bridge the gap between ground-based sampling and remote sensing techniques. Once we stitch together the raw UAV photos, we classify pixels in the resulting mosaic image as either lichen or not lichen. Currently, we're working with a collaborator in Alaska to scale up our lichen cover estimates to entire caribou ranges. To do this, we aggregate pixels from sub-centimeter resolution UAV imagery up to 30-meter pixels that align with Landsat imagery. The resulting map shows fractional lichen cover for an area that encompasses the 40-mile, Claza, Clear Creek, and Heart River caribou ranges. This research excites me because it incorporates an emerging technology that is cost-effective and produces high-resolution habitat data, and it could really change the way we collect data on things like vegetation structure and composition. I want to thank the W. Garfield Weston Foundation and WCS Canada for supporting my work, because this fellowship allowed me to invest time and energy into exploring new ways to collect habitat data that I otherwise wouldn't have considered. In the end, I think the final products and management recommendations that come from this research will be much stronger as a result of this award.